Hello, I'm Robert, and I wrote an article last year called 10 Reasons Not to Live on Mars, Great Place to Explore. And I've put up a few videos from it on this channel as well. Well, in this video, I want to go a little bit further beyond that and look at the solar system generally. And so I believe that the best attitude to the solar system at the moment is that we should be going out into space we're in the process of exploration and open discovery, open-ended exploration with no end time, no end date. And that we should also be looking for solutions of the problems on the Earth, that we have here on the Earth. And I firmly believe that we should not go into space hoping to make a fresh start and to escape disasters on the Earth. Because there's nowhere, it just turns out that there's nowhere in our solar system. We live in a solar system where there is no other habitable place that's anything like the Earth. And I think it's best to recognise that. And we will then have a practical and sensible space program if we understand and recognise that we can't escape from the Earth. We need to find solutions here. And so I'd like to fill that out a bit and explain why that is. So, many people do have this idea of going into space to escape from the Earth. Well, what tends to be forgotten is that there are many places on the Earth that we don't colonise. So it's not like it's an imperative that you have to colonise everywhere. There's nobody setting their sights on the summit of Mount Everest, for instance, as a place to colonise. We all understand that if you were living on the summit of Mount Everest, you would have to be continually importing oxygen. And to make it a more exact analogy for the ideas of space colonies or colonies on Mars or even Venus or whatever, you would have to make all your oxygen. You can't import it from the rest of the Earth. You would have to make it from the ice and snow on the summit of Mount Everest, or all the oxygen you need to breathe. And nobody really has that as an aim, and they're not frustrated because they're not permitted to do that. It just isn't something that people even think of trying to live permanently on the summit of Mount Everest. And there are many other places on the Earth like that, which are much more practical places to live permanently, but people don't have the idea of colonising there, although you do get permanent settlements there. And so examples there are, for instance, Antarctica. So you have the permanent science stations in Antarctica where you do get scientists living there. Particularly scientists tend to be in most of these places. They're the people who are most interested in living in these places long term. And they may spend months or years at a time in these places, like Antarctica. There's the high Atacama Desert, and sometimes you also have astronomers with their space telescopes, or you have the life scientists and biologists studying extreme forms of life that live there. And then, for instance, also high up in the tops of the mountains in Hawaii. And I think that is what the sort of human presence that we're going to get in the outer solar system as human colonization, but I don't think of it as colonization, but exploration of the solar system continues. And this will happen in a natural way. And we don't need to try and make lots of people go to these places. They're going to go there naturally, and there's nothing there for the ordinary person except to visit it as somewhere interesting to go for a short time. And I think this is where we went from with Apollo. So the Apollo astronauts, they were not scientists. And the mission, as it was originally envisaged, then it was just to try and get human beings to set foot on the moon. And originally, there was practically no science component to it. And then scientists came up to mission planners and said, what are you planning to do about returning rocks from the moon? And they hadn't even thought of this. And that shows how little it was science orientated. And science was an add-on to the Apollo, to the aim of getting humans to the moon. And when the humans got there, then to your average person who's not a scientist, the moon is not really that interesting. It's quite fun to start with. So you're bounding around on the surface, and days you could have gone over the days to weeks. But it wasn't like the astronauts, quite understandably, they were not I'm utterly fascinated by what they found on the moon, in the way that a scientist would be. And so they went and they did collect the rocks, because they'd been told to do so, and they went around and they had geology classes on the Earth in order to train them to help them to spot rocks on the moon. But it was only with the very last mission to the moon that we sent our very first scientist, and the only scientist to go to the moon. And this was the geologist who actually trained the Apollo astronauts. He got to fly on the very last mission to the moon. And he, as a geologist, was utterly fascinated by what he found there. And for him, his visit was all too short, and it passed very, very quickly. And by the end of his visit, he hadn't realised how quickly the time was passing, and he needed to be called back by because he hadn't realised how quick time was passing as he was finding all the fascinating rocks on the surface of the moon. And he brought back a rock that's been dubbed the most interesting rock to have been returned from the moon, because of course he was looking at the moon with a geologist's eye. And this is how it's going to work in the outer solar system, and I think at present, because it is most interest to scientists, especially for long-term interest. And it's the same for Mars. So Mars may look really fascinating in the pictures. It might look a bit like the Arizona desert, but actually to human eyes it's much more like the moon. Imagine the moon but kind of brown and rather dark in colour. And these pictures that you see of Mars, if you see a slight hint of blue in the picture, or if there's a kind of bluish grey even in the picture, then you know for sure that the colours have been digitally manipulated. In fact, just about every single picture you see of Mars has been digitally manipulated. And that's because the Mars atmosphere, there's a very fine dust in the upper Mars atmosphere, and unlike the dust on the Earth, it filters out blue light. And it leaves only the reddish and yellowish tinges. And so Mars is sort of the opposite of the Earth, that the sky is this reddish but rather dark because it's further away from the sun and there's a lot of dust in the atmosphere. And then at night, at sunset and sunrises on Mars are blue. It's not a big bright sunset like we have on Earth, but there's kind of blue patch around the sun when it rises and when it sets, because it's kind of the reverse of the Earth. So if you were on Mars, then everything would seem this greyish, reddish brown, and human eyes aren't used to this. And so we would not be able to see colours very clearly on Mars with unaided eye. Everything would look pretty much the same colour. And that is why the photographs are digitally enhanced, in order to make it look as if it was illuminated by a normal Earth blue sky and sunlight. And when in fact it's illuminated by this kind of dark reddish brown, so it is very difficult for human eyes to pick out colours. And so we see the Mars surface at its very best through the eyes of our rovers there, much better than we would with unaided eyes. And again, our rovers, they don't need to be encumbered by spacesuits. They can just drive around without having to have big clumsy gloves and things. And so they can be built so that Mars is just fine for them, so that they are in their element. Humans will never be in their element on Mars. And this is the same throughout the solar system. And there's nowhere in the solar system, in fact I argued in one of my articles that I think the Venus clouds are by far the high idea of habitats floating in the clouds of Venus. Then this is the most Earth-like environment there is in the solar system. At a certain height in the Venus clouds, you get one atmosphere pressure, you get the same temperatures as on Earth, same atmospheric pressure as on Earth. You've even got nitrogen, a respectable amount of nitrogen in the atmosphere. You've got a respectable amount of water and sulfur. It is mixed up with sulfuric acid, but you could separate that. And then the actual building construction is much easier there as well. So anywhere else in the solar system, you wouldn't be able to build a house like you can on the Earth. You couldn't just go to Mars and build a house. You can't go to the Moon and build a house just from bricks. If you've looked at the ISS and seen pictures of the ISS, and you know how it's made of cylinders with very few windows. And that's because the ISS has to contain many tons. It's about 9 tons if it was full earth pressure, many tons per square meter of pressure pushing out. So you need this very, very strong, robust, and it's very difficult to engineer anything that has not got an equipotential equilibrium surface, normally cylinders or else spheres or something of that sort, very rounded surfaces. So again, anywhere in the solar system is not very easy to colonize because all your buildings have to be built like this. They have to be able to withstand tons of pressure against every surface, and it's extremely difficult to build windows. Very high tech building windows. And greenhouses also, they would have to be made of something very, very strong in order to withstand holding in all the pressure of the air. You can't just build a normal greenhouse on Mars. It has to be some very robust construction, and most probably kind of bubble shaped as well. So, there's nowhere in the solar system that's anywhere as easy to build places as it is, for instance, on the summit of Mount Everest or Antarctica or in the Atacama Desert or anywhere like that. And so I know that they develop these ideas for ways that you could build habitats in these places, and the idea of eventually maybe becoming self-sufficient so they don't even depend on the Earth. Now, if that was possible in space, it would be far, far easier on the Earth than to do it in space. So that's why I can never see, I just can't see it working at all to start a settlement in space and try and make a new fresh start anywhere in the solar system, and including my favourite of Venus, where I think there's most Earth-like habitat, but still it's nowhere like Earth. You have to have some other reason to go there with present-day technology. And the reason is because anything you could do there, then the same amount of effort, the same amount of human hours put into building your habitats, you could build many more of them on the Earth, in the deserts. So it's never going to make economical or practical sense to build habitats in space, because everything you could do in the Earth. And there's lots we can do, there's lots of places we can valuably colonize on the Earth, because there's the process of increasing desertification and the cutting down of the rainforests and turning into dust bowls. Even in the States, going back to the prairies, which turn into dust bowls, reversing desertification in many places in the world. It's a massive program, massive problem worldwide. In fact, I was born in Madagascar, and this is a country that is suffering tremendously from deforestation and the soil being lost into the oceans. And this is something which we could reverse much more easily than we could start up new colonies somewhere in space. And we could use the same technology, and there's some ideas that are really quite a bit related to space settlements, such as these seawater greenhouses, which use seawater which is cooled, cools down the greenhouse and also evaporates the seawater. This is in desert places that are close to the sea, and then it actually creates fresh water for the greenhouse, fresh water for the desert, replenishing the aquifers and irrigating the area around the greenhouse, and it actually creates salts as well. And so it's sort of a little bit like the space settlement ideas, but it's using seawater, and of course we've already got oxygen in the atmosphere. It's sort of quite self-contained though, because it's this circulating thing where the whole thing is the sun and the seawater all working together. And quite possibly some of the ideas that we might develop, I'm not saying we won't have any habitats in space, because we will need them for our scientists out there, apart from anything else. And in these habitats they will have to solve the problems of closed systems. And you also have your tourists and your hotels and things in space. And you'll have miners getting resources from the Earth. And but I'm just saying that it'll never make sense to go into space as your end goal. that you go into space because that's where you want to live, because it's easier to live in space. It'll never be easier to live in space than on the Earth, at least with present day technology. Now, there may be some magical technology in the future where all this will change, and we'll can meet that situation when it arises. For instance, 3D printers maybe eventually might make a huge difference to all this. But we shouldn't plan around that at present, because what we know about the future is that it's never as you predict it. Some things may be and some things not. And very much the same applies to terraforming. In my trouble with Terraforming Mars, I've talked about how very different Mars is, how very different Mars is from the Earth. And it would be really hard to terraform Mars, I believe, because it is so different from Earth. And so and of course that's when people talk about making a fresh start and escaping disasters on Earth, then everybody acknowledges that Mars is totally not at all habitable like Earth at present. You know, in order to get Earth at all like Mars, then we'd have to get rid of 99% of the Earth's atmosphere, you have to get rid of all the oceans, and you would have to get rid of 80% of the ice cap for Antarctica to get down to the level of ice that there is on Mars. Or on the entire surface of Mars, it's equivalent to 12 meters over the surface of Mars. If you got rid of 80% of the Antarctica, it'd be equivalent to 12 meters over the surface of the Earth. And then you also would have to get rid of the magnetic field, stop continental drift, and even then, you're not done. You have to reduce the sunlight to a half of what it is, more elliptical orbit, and then you have to reduce the gravitational pull, so it's a third of what it is. And under a third of Earth's gravity, we don't actually know if it's possible for human beings to live in those situations. It's possible, for instance, that your bones can't grow, so it might be impossible to have babies or children in low gravity. This is something that happened to some rats that were the Soviet put into space, and they tried a 6th gravity, so rather less than Mars. We have very little understanding of what happens in Mars conditions because we haven't done the experiments. But whether it's practical or not, whether it's possible or not, then there's still a question of whether it's sensible or practical or economic to do it. And I just can't see that happening in the near future because it is so very inhospitable. And because Mars is so different from the Earth, then terraforming is far from straightforward. Because if you were to transfer the Earth's atmosphere and ecosystem so magically you could transfer it to Mars, it wouldn't work on Mars because the planet is so different from the Earth. So Mars needs its own solutions. Anyway, you can look at all that in my Trouble with Terraforming Mars article. And but anyway, terraforming is something that's going to take thousands of years as well. And so at least for the first few centuries, it's now believed, people were more optimistic back in the 1970s, but even the most optimistic people now would think it would take at least thousands of years, and most likely maybe 100,000 years, and that is if it works, which nobody knows if it would work. Because there may be many possible end states of a planet, and we on the Earth are only in one of them. And Mars, as it is now, it seems quite likely that's a possible end state of a planet with life in the Mars location, in the solar system. And you might then have to fight against that in order to try and make it anything like the Earth. And so you'd have to set up these systems. It might be you just have to have mega engineering from now on into the endless future in order to keep Mars terraformed. And then what project have we ever done that lasts for thousands of years, a technological project, in order to reach completion? So I think that we can definitely, it's great to think about ideas like terraforming. And it could arguably be said that all the thoughts that have been put into terraforming Mars has been a great contribution to understanding better how the Earth ecosystem works and help us understand how exoplanets work. And who knows, maybe in the future these ideas will be used, but I think we are a long, long way away from being at the point where it either makes any sense, or any practical sense, or is of any value to try to terraform Mars, or has any chance at all of success. What we should be doing instead is terraforming, using the ideas and the thoughts behind this, indeed, but what we should be focusing on terraforming the Earth. So, for instance, reversing desertification and dealing with the deforestation, with the soil loss, and all these things like that. And in the solar system, we should be heading out with a process of open-ended exploration, heading out and seeing what we can discover there. And there's much of tremendous value that we can discover in space, and particularly, I think, in terms of biology, surprising the gap of our knowledge that that if you work out evolutionary steps from amino acids to human beings, then you look at the most primitive cell that we know, then where would you think that would be? You would probably think that was about the first step. Well, it turns out that there have probably been, that in terms of the complexity, evolving complexity of the DNA, then there should have been as many steps of evolution between amino acids, which are the basic building blocks, which you get even in meteorites, all the way up to the primitive cell, which is actually an immensely complex thing. So it's got a DNA, RNA, transcriptase, proteins, enzymes, the cell wall, a million different chemicals, all in some intricate dance. And it's absolutely impossible that you could just mix some amino acids and get a cell. So there's as many steps of evolution between amino acids and this basic cell, the simplest cell that we know, as there are between the simplest cell and ourselves. So there's the equivalent of going multicellular, and you're developing a nucleus, and you're developing a backbone, warm-blooded, and all the other steps that have gone all the way to us. There's the equivalent of all those steps have gone from the amino acids to the primitive cell. And we don't know anything about that gap. And it's a huge gap in our understanding, and particularly on Mars, but also in other places in the solar system, it's possible to fill this gap. And when you think about how important life is to us, of course we are alive, medicine, very important, but also we're surrounded by living processes, wooden things, wooden things like that, and we're completely surrounded by products of life, plastic and oil. We're so dependent on the products of life. Think about what we could, what understanding the process of evolution of primitive cells, and maybe some life has gone in a different direction from the way it went on the Earth. And what new things, maybe even new technologies, new nanotechnology, new biological products. It's almost, we have no idea what we're going to discover in the solar system. Now we realise there's at least a potential, it seems a very strong potential, we'll find out things about life. But it's likely to be a very difficult and long process of finding it out. Science takes a long time anyway, and then there are various reasons why this is really hard to discover, because the life is very expected to be very elusive. We're talking about traces of organics from billions of years ago that may still remain on Earth, on Mars, to this day. Very much degraded, but still plenty for us to be able to learn a lot about how life actually was way back then. I'm also talking about very, very hard to discover present day life that may be in just a few cells per like a few microbes per ton of soil maybe. Very sparse, slowly growing, maybe with lifetimes where each microbe will live for 1,000 years before it reproduces. So it's going to be really quite hard for scientists to discover, but there's amazing things for them to discover. And so I think we should think about like that. And when we have projects in space, then you think in terms of open-ended exploration, and also in terms of thinking what can these projects do for the Earth. So either you're going there for your own sake, of course adventurers and explorers as well, and tourists, but think and I think the idea of just setting up a colony when you don't know what it's for, that's, I think, is where you're going to be going all wrong, because it's not, it just isn't a good place for the likes of ordinary people like ourselves to just head off there if you're not a scientist and really very, very interested in what you're doing there. And if you are, you build your colony around that. So you might have an orbital colony around Mars in order to explore Mars, and you design it in such a way that it's a very good research station, and that's why you build it. You don't build it just as a place for someone to go to live, because that just makes no sense at all. It makes no sense at all to go into space as somewhere to live, because you can build your homes far, far better on the Earth. That would be just like going to the summit of Everest because you think that's a great place to live.